Good morning. Today I will be presenting you our project for the unit of sustainable engineering. Our topic for this team is a sustainable alternative for cement in concrete. Our team consists of Sudham Zoiza, Chenali Jayawardana, Hasun Kalinga and me, Yasal De Silva. The whole project was divided into two sections. One of them was to investigate the problem and to basically have a clear understanding of the product we have right now. The second part involved identifying the issue and issues related to the problem and how we can minimize the overall effect of the issues by creating a sustainable approach to the problem and finding an alternative. Did you know that the world's secondly most commonly used resource is concrete, coming after water? It absolutely is. Concrete is the most abundant building resource in almost every built-up area in the world. It is versatile in its applications, and that is the main reason as to why it is so commonplace in urban areas. In the following slides, we will explain how we managed to find out more about concrete and the use of cement in it, and how we approached in finding an alternative about cement in concrete. The importance of using sustainable alternatives to cement in concrete is quite apparent, especially in the 21st century. Lowering the carbon footprint of the use of concrete is the main point. Global warming, being directly related to this, happens to be the key reason to find a suitable alternative. Next, to minimize the resource depletion, the use of cement in concrete usually results in the use of raw materials, of which the majority are non-renewable. Therefore, this means that these resources are to run out after complete extraction. The use of concrete, however, moreover causes land degradation. That means at the end of the period of use of concrete, it is not an easy material to dispose. Concrete stays around for hundreds of years possibly, and that means landfill issues. You can demolish and disintegrate buildings, but the effect will be the same. A suitable alternative can also reduce the cost of production of concrete, and finally reducing the contribution of greenhouse gases, which links to the first point to a certain extent, reducing the effect on global warming. Here is a table of the raw materials of concrete. Concrete contains 7 to 15% cement, 25 to 30% sand, 35 to 45% coarse aggregate, and 14 to 21% water. Here, as shown in the table, only water is classified as a renewable resource, which goes to contribute to the insustainability of cement as an alternative in concrete. Moving on to the properties of concrete. Concrete shows two states. One which is hardened and is used as the final purpose, and fresh concrete, which is the state during pouring into molds, structures, after mixing and transport. Hardened concrete has soundness, compressive strength, durability, and water absorption. Fresh concrete has effective adhesion, bleeding, workability, segregation, plastic and thermal shrinkage, and a certain setting time depending on the mix of concrete. Here is the manufacturing process for cement. Initially, all the raw materials are batched. This produces carbon dioxide in the process. Then in the mixing, where the mixture is prepared to use in molds or for the related application when it's fresh or to be transported. The carbon dioxide here are mostly due to energy consumption. If transport does take place, again CO2 emissions are abundant. Next up, addition of water to correct the mixture after the transportation and placing the mixture happens at the site. Concrete is mostly used in structural purposes and in constructions. Tunnels, pipelines, storage containers like drainage tanks, precast products, and decoration are among the many. The key point, as we mentioned earlier, is the compressive strength that puts them to this purpose and usefulness. Moving on to the problems in using concrete. The raw materials used for the production are all non-renewable except water, and that imposes the first problem here. It is not sustainable as resource depletion is the main point. Extraction of the raw materials create pollution by greenhouse gas, and it results in landscape degradation by mining techniques. Noise pollution is also a problem at mining. The production of concrete involves the carbon footprint of the raw material itself, which is high. High consumption of non-renewable materials and air pollution are also a few. Plus the use of non-renewable energy if renewable forms are not available. The release of dust can irritate human eyes and cause breathing problems. In fact, 30 to 70% of the production of cost of concrete itself is energy. Water pollution is a threat as it releases mercury into water. Concrete forms a hard layer covering the topsoil, so the topsoil cannot absorb water. Soil pollution is also an issue as it increases soil pH. Air pollution at the end use of the concrete is one of the main problems of concrete, along with concrete waste taking around 50 years or longer to dispose. Concrete is not economically recyclable as it needs to be crushed and to be reused once again, which needs more energy and large machines. Possible replacements for cement in concrete are fly ash, lime, and silica fumes. Fly ash reduces the air pollution, uses less raw material, and therefore minimizes resource depletion. Lime also minimizes the use of raw materials, reduces carbon footprint and air pollution. Silica minimizes resource depletion again and the use of non-renewable resources. Our alternative is fly ash, and we decided that as the most feasible since it has a high compressive strength and has cementitious properties. Carbon footprint will be lowered and the use of non-renewable material will be lowered compared to cement during production. Fly ash can replace up to 20 to 30% of cement, and a reduction of 70% in carbon dioxide emissions are possible by modifying the mix of concrete to fly ash. Fly ash is a coal combustion product, so no raw material is extracted, only reused. Embodied energy will be reduced by 30 to 40%, so it is more economical. Fly ash in concrete increases the workability of fresh concrete, which will have the high strength and better resistance to weather change. Tensile strength is also increased, which reduces cracking. After careful study of the concrete properties, we figured out many flaws in the material and the use of it. Research led us to several alternatives that were more feasible and provide more sustainable results than cement in concrete. We filtered the properties and wanted to see what is the best alternative. And in the end, fly ash is the most effective one since it is a byproduct of coal combustion and contributes to a more sustainable environment. Thank you.